There is this fundamental assumption that basically underpins almost everything we do.
Right. And science, engineering, just daily life, really.
Exactly. When we talk about the foundation of mathematics, there's this unspoken expectation of absolute givenness.
Oh, sure. Like engineering a skyscraper.
Yeah, exactly. Before you pour the concrete, you have to dig down to the bedrock.
You need a solid base.
And in math, we've always been taught that the bedrock is the number 0. The empty set, the absolute void.
It's a clean slate.
Right. You lay that down, and the teacher points to the chalkboard and essentially says, there it is. That is the absolute bottom. From nothing, we begin to count.
It is a deeply, deeply ingrained framework.
It really is.
It's binary, and as a cognitive tool, it's incredibly comforting. I mean, we have this innate psychological desire for things to start from a clean slate.
Yeah, an empty box.
Exactly.
Mm-hmm.
You have nothing, and then suddenly you have one thing. It feels clean.
It feels logical.
Right. It feels logical. It's basically the entire basis of how we structure logic itself.
But then you step into the world of fundamental physics.
Yeah.
Or ontological mathematics, and you start pushing on that empty box.
You start looking a little too closely at it.
Yeah, you start asking what the box is actually made of, and suddenly that pristine void starts to look incredibly suspicious.
Very suspicious.
Because when you actually interrogate the concept of 0, you realize we are looking at a foundational landscape that might be entirely inverted. The void isn't the bottom.
No, it's not.
A void is a construct.
It is arguably the absolute definition of a conceptual blind spot in modern foundational sciences.
A blind spot, wow.
Yeah. I mean, we have built these towers of magnificent complexity, right? Quantum mechanics, general relativity, advanced topology.
Sure.
But we rarely, if ever, question the dirt those towers are actually built on.
Which brings us to today. Welcome to another deep dive. Today, we are immersing ourselves in a stack of sources that are, they're dense.
Highly technical.
Highly technical and, frankly, utterly mind-bending. We are exploring a 2026 paper by Philip Lilien and the UCTE Foundation.
Right. Closure mathematics. The orthogonal emergence of mathematical form.
That's the one. And we've been poring over the core paper, the associated executive summaries, the supplementary diagrams, the whole package.
It is quite a massive package.
It really is. And let me just warn you up front, to the listener, this is not a gentle stroll through arithmetic.
Not at all. The implications here stretch from the underlying philosophy of how mathematical domains emerge.
Right.
To the literal physical structure of the cosmos.
Right.
I mean, it bridges the gap between pure mathematics and theoretical physics.
Yeah.
In a way that demands we abandon some of our most cherished axioms.
Exactly. So the mission for you, the listener, today is substantial. We are going to completely dismantle the way you conceptualize mathematical origins.
We have to shatter the idea that mathematics begins with the number 0.
Or counting to 1.
Right, or some pre-existing empty set.
And once we've cleared that away, we are going to rebuild reality from the true ontological ground up.
From the very bottom.
Because the stakes of this paper aren't just about, moving symbols around on a chalkboard. This framework claims to literally derive the physical universe.
The specific masses of elementary particles.
Right. The gauge forces of nature. All the way up to the existence of human consciousness.
All using a single, continuous, unbroken logic.
What the authors call coherence. So where do we even start with this?
Well, the overarching theme here is a complete regrounding.
Okay, regrounding. Unpack that for us.
If we look at standard classical mathematics, right, frameworks like Zermelo-Fraenkel set theory or modern category theory.
For the stuff they teach in universities.
Exactly. They're undeniably powerful. But they typically presuppose that mathematical objects and the domains they inhabit already exist.
They just take them for granted.
Right. They assume the structural building blocks are just there, waiting in some platonic realm to be manipulated.
Like Lego bricks already sitting in the bucket.
Perfect analogy, yes. Closure mathematics, on the other hand, refuses to take that for granted. It steps back and asks a much more radical question.
Which is?
Under what specific ontological conditions do mathematical domains become possible in the first place?
Oh, wow.
It is not asking how the game of math is played. It is asking how the board, the pieces, and the rules emerge from the raw ether of potential.
Right, so it's like trying to explain chess, but instead of starting with, here's how the knight moves, You have to explain the fundamental physics of why wood can be carved into a horse shape,
Exactly.
and why a grid can hold conceptual meaning at all.
Yes, that's exactly it.
Okay, so to do that, to rebuild math, we have to clear out the old foundation. And that means we have to address the elephant in the room immediately. We have to deconstruct zero.
We absolutely do. Because classical mathematics treats zero, or a singular scalar point, as the ultimate primitive beginning.
It's the unquestioned starting line.
It is the starting line. But closure mathematics argues, quite aggressively actually, that starting with zero is already starting far too late in the causal chain.
Too late.
Yes. The paper makes a profound statement. It says, scalarity is already a reduction.
Scalarity is already a reduction. Okay, let's break that down.
Let's think about the mechanics of a scalar. A scalar, a single numerical value on a line. It inherently presupposes a regime of comparability.
A regime of comparability, meaning what exactly?
It assumes that there is already an established mathematical environment where you can definitively say something is greater than, less than, or equal to something else.
Ah, okay.
It takes the existence of the number line itself as a given.
Wait, let me stop you there because I want to make sure I'm completely internalizing this. If I have an empty room and I say I have 0 chairs,
Okay, good example.
you're saying that the concept of 0 chairs assumes that the category of chairs, the space of the room, and the cognitive act of counting already exist. You can't have a 0 without a pre-existing measuring stick to map it onto.
You're already assuming a highly structured, differentiated environment. You are assuming a specific, stabilized domain where counting is even a valid operation.
Right.
So, mathematically and philosophically, 0 cannot be the absolute, unconditioned origin of everything.
Because it needs context.
Because 0 requires a pre-existing context to make any syntactic sense. If you strip away the measuring stick, the space, and the concept of counting, what is 0?
It's nothing. I mean, not even nothing. It just doesn't mean anything.
It loses all definitional power. Exactly.
Okay, so if 0 isn't the true origin, if it's just a downstream consequence of a measuring system, what is the actual bottom?
Well, the sources introduce a concept that they call Zeta Naught.
Zeta Naught, written as the Greek letter zeta with a little 0 subscript.
Yes, and they present this as the true, unconditioned beginning.
The text describes it as an isotropic, pre-differentiated state of coherence.
That's right.
Okay, let's unpack those terms because they are doing a lot of heavy lifting. Isotropic, in physics, usually means looking the same in all directions.
Correct.
It means there is no privileged direction, no established metric, no positive or negative sign, no assigned numerical value.
Yes. It is pure structured potential. And the most vital thing to grasp here is that it is not a void.
Not a void. Okay.
No. A void implies an absence within a container. Zeta Naught is a condition of ordered potential that contains all possible structural directions and dimensionalities implicitly.
Implicitly, so they're all in there.
They're all in there, yes. But without favoring any single one of them over another. It is perfect symmetry before the concept of symmetry has anything to act upon.
I'm trying to visualize this, which I know is dangerous when dealing with pre-spatial concepts.
It is tricky, yes.
Let me try an analogy. Is Zeta not like a massive lump of completely unformed clay? Like, it possesses the potential to be sculpted into a statue or a bowl or a house, but right now it hasn't been differentiated into any of those forms. Wait, actually, let me correct myself before you jump in. That doesn't work.
Why not?
Because clay has mass, it has physical dimension, it occupies a 3D coordinate space. Zeta Naught has none of those things yet.
Spot on. Yes.
It's more like, I don't know, the abstract possibility of a canvas before the very concepts of up, down, left, or right have been invented.
That is much closer.
It's totally pre-scalar. But here's where it gets stuck. If it has no direction, no scalar value, no mass, no geometry, how is it functionally any different from just nothingness? Like, why invent a new Greek letter for a void?
That is the exact trap the paper warns against. And it is the crucial distinction we have to navigate here. Zeta Naught is emphatically not nothingness.
Okay.
And it is explicitly, formally not the number 0. The text uses the mathematical shorthand to emphasize this, establishing that 0 is strictly unequal to Zeta Naught.
0 does not equal Zeta Naught.
Right. Confusing the two is exactly what leads to the pervasive philosophical distortion that the universe, or the foundation of mathematics, emerged from absolute barren nothing.
Oh man, the whole creatio ex nihilo problem that physicists and theologians have been arguing about for centuries.
Exactly. Zeta Naught is the ontological condition that makes the concept of zero possible. It is the pre-structure.
The pre-structure.
Think of it this way. If you imagine nothingness as a dark, empty room, Zeta Naught isn't the room. It is the latent physical laws and spatial coherence that allow a room to conceptually exist in the first place.
Wow.
It contains all directions, all possibilities, in a state of perfectly implicit balance. It is full, not empty. It is a plenum of potential.
Well, plenum of potential. Okay, I'm with you, but that creates a massive mechanical problem, doesn't it?
How so?
Well, if Zeta Naught is this perfectly balanced isotropic state where no single direction is privileged, how does any actual mathematical structure ever begin?
That is the big question.
Like if the universe or the math decides to draw a single line in this pre-space, it has arbitrarily chosen a direction, right?
Yeah.
It has violated the fairness of isotropy. It's picked a favorite child. How do you get from perfect, featureless potential to a structured reality without violating the symmetry that defines the starting point?
That is the defining crisis of emergence. And you are entirely correct. Drawing a single line or isolating a single scalar point is mathematically unlawful within this framework.
Unlawful.
Yes.
Yeah.
You cannot just arbitrarily elevate one direction over all infinite others without a causal mechanism.
So what's the workaround? How does structure emerge without violating that foundational symmetry?
The framework provides a remarkably elegant, almost paradoxical solution. The first lawful act of structure cannot be a point or a line. It must be orthogonality.
Orthogonality.
Meaning,
Right angles, perpendicularity, and mutual independence.
precisely, to break the symmetry of Zeta Naught without arbitrarily privileging one single axis, differentiation has to occur through the simultaneous emergence of mutually independent directions.
Simultaneous.
Yes, if two directions emerge at the exact same moment, completely orthogonal to one another, they do not violate the isotropic balance because neither one is entirely dominant.
Because they define themselves strictly in relation to each other's independence.
Exactly.
Oh, wow. So you don't just get one line in the void. You get two lines, completely distinct, fundamentally independent of each other, snapping into existence at the exact same mathematical instant.
That's the mechanism.
They hold each other in tension.
Yes. The text formalizes this genesis event, not as a zero-dimensional point and not as a one-dimensional vector, but as a mathematical bivector.
A bivector.
A wedge product of two independent vectors. This represents the concept of minimal plurality.
Minimal plurality.
It is the absolute smallest form of differentiation that allows structure to emerge from the potential without collapsing into an arbitrary privileged fragment. It requires two distinct identities to create the first lawful boundary.
I really want to pause and let that marinate for a second, because if you accept this, it forces a massive paradigm shift in how we think about reality.
It changes everything.
What this framework is declaring is that relation precedes number. We do not start with the solitary number 1 and build a universe by adding another 1 to it. We don't start with a single isolated identity. We start with a relationship.
We start with tension.
The relationship, the orthogonal tension between independent directions, is the fundamental, irreducible building block of existence. Numbers, counting, geometry, physics, all of that is downstream architecture.
It completely upends the pedagogical script of human history. I mean, we teach children to count linearly, right? 1, 2, 3.
Yeah.
We teach them that isolated identity is the primary feature of reality, and that relations are just things that happen between identities later on.
Like you have an apple, I have an apple, and then we relate them.
Exactly. But nature, according to the mathematics of closure, starts with the orthogonal relation. The very act of scalarity, the assignment of a static value to an identity, is already a localized downstream consequence of this initial relational split.
So if Zeta Naught is the true relation-rich source, and this orthogonal split is the first lawful act of creation, we have to circle back to the question of zero. What actually is the number 0 that we use every single day? If it's not the bedrock, what is its function?
Well, the paper uses this incredibly evocative phrase. It refers to 0 as a coordinate veil.
A coordinate veil. Man, that sounds cool.
It is a beautiful and highly precise term because 0 is, in a profound ontological sense, an illusion.
An illusion.
It is a local projection artifact. It masks the deeper, roaring, isotropic source beneath it.
It's like, okay, imagine you're at a massive shopping mall and you look at the directory map. There's a big red star that says, "You are here."
Okay.
That star isn't the center of the Earth. It's not the origin of the universe. It's just a local anchor point specifically tailored to help you navigate your immediate surroundings.
Sure.
0 is the "you are here" sticker of math.
That is the phenomenal way to visualize it. Zero is strictly and fundamentally domain relative.
Domain relative, meaning it changes depending on where you are.
Exactly. It does not have a universal identity. It behaves completely differently depending on the specific mathematical layer or domain it happens to be operating within.
Give me an example.
For example, if we are localized in the layer of integers, whole numbers, positive and negative,
Right.
zero acts as a bidirectional symmetry point. It is the fulcrum on a seesaw, perfectly balancing the tension between positive and negative infinity.
Right. But if we shift our perspective and move into the layer of real numbers, the continuous continuum of decimals and fractions that map physical distance.
Then zero loses that fulcrum identity. It becomes a neutral metric location. It's just an arbitrary starting tick on a continuous ruler.
And if we ascend to the domain of complex numbers, which involve imaginary axes and rotations, zero shifts again, doesn't it?
It does. It becomes the absolute origin of phase. It is the center pin around which the complex plane rotates.
And in standard abstract algebra, it's just the additive identity element.
Right.
It's defined purely by its function, the thing that changes nothing when you add it to something else. It has no structural meat on its bones outside of that operation.
So if we step back and connect this to the overarching philosophical argument of the paper, zero is essentially just a local origin marker.
Tailored to whatever domain we're in.
Dynamically tailored to whatever specific structural domain has already managed to stabilize itself. It is an artifact of a stabilized system.
Right.
And this brings us to the core warning of the UCTE authors. Conflating this local operational marker with the absolute metaphysical source of reality is the original sin of modern physics.
It leads directly to the logical absurdity that the universe exploded out of nothing.
Yes, the universe did not come from a coordinate marker. It did not come from an additive identity. It emerged from the infinite relation-rich potential of Zeta Naught.
Okay, so we've cleared the foundation. We have this pre-scalar ground potential, Zeta Naught. We have the first lawful act of structural emergence, which is orthogonality, spitting out these independent bivector relations. But raw directions flying around in a state of tension isn't a universe, and it certainly isn't a math class. How do these volatile, newly emerged directions turn into the robust, permanent mathematics we actually use?
They have to stabilize.
Right. How do we get stable systems like arithmetic, algebra, and calculus? Because those independent directions have to lock into place somehow.
And that locking mechanism, that process of stabilization, is what the framework defines as closure.
Goes right here?
Closure is arguably the most important operational concept in the paper. It is the stabilization of these orthogonal directions into persistent, self-consistent, admissible regimes.
So what happens without it?
Without closure, that initial orthogonal differentiation would just be a transient, explosive fragmentation. It would tear itself apart and dissolve back into potential.
You wouldn't last.
No. Closure is the mathematical boundary condition that allows these emergent directions to lock in, to persist over time, and to form a closed domain capable of supporting logical operations, continuous transformations, and physical laws.
So, mathematics as we know it is basically a series of these stabilized closure layers stacked on top of each other in increasing relational complexity.
Stacked orthogonally, yes.
The text actually walks through what they call the 5 canonical layers, demonstrating that math isn't a linear timeline of human discovery, but an orthogonal stack of emergence. Let's walk through them because this really clarifies the mechanics.
Let's do it.
First, at the bottom of the stabilized stack, you have the natural numbers, the counting numbers. 1, 2, 3, 4.
Yes, the foundational layer of discrete succession. It is the simplest stable regime, but it has strict limits.
Right, because you can add natural numbers forever and stay within the layer.
But the moment you try to subtract a larger number from a smaller one, say 3 minus 5, the layer breaks.
You cannot resolve that relation within the closure rules of natural numbers.
Exactly. To solve it, the system requires a new orthogonal projection. It demands a new closure regime to handle a new type of relation.
Which forcefully emerges the next layer,
Yeah.
the integers. This layer introduces the axis of bidirectional symmetry. You've unlocked the concept of the negative, you have a new direction, but again, you hit a wall.
You can add, subtract, and multiply integers, but try to divide 3 by 2.
The integer layer shatters. It can't process the spaces between the discrete points.
Which forces the emergence of the real numbers. This layer introduces the profound concept of continuity and metric extension. The infinite gaps between the integers are filled in. The structure becomes a continuous continuum. You can divide anything by anything.
Almost.
Almost. And this is where it gets brilliant, because you're moving along the real number line doing your algebra, and suddenly you need to take the square root of a negative number.
And the system completely halts.
I remember being in high school algebra when they first introduced imaginary numbers. If you're anything like me, it felt incredibly jarring, almost offensive.
Oh, absolutely. It felt like the teacher was cheating. Like, oh, the math doesn't work here, so we're just going to invent a magical letter I, pretend it solves the problem, and move on. It felt like a purely synthetic human invention glued onto real math.
A very common and an entirely understandable reaction, because classical education treats it as a synthetic workaround. But closure mathematics completely rehabilitates that intuition.
Really?
Yes. According to this framework, taking the square root of a negative number isn't a cheat. It is the exact moment the real number system exhausts its relational capacity. The only mathematically lawful way to resolve that tension is, once again, a new orthogonal projection.
So it actually was a new dimension?
It literally was a new dimension emerging. It wasn't an arbitrary invention. It was the unavoidable stabilization of a completely new, mathematically lawful axis of rotation and phase locking into place.
That is so validating. That intuition of this is a whole new direction was ontologically accurate. The complex layer is the layer of rotation and orthogonal phase. It's where math learns to spin. And above that, we have the functional layer, the domain of operator spaces, matrices, and continuous transformations.
So mathematics isn't a single flat continuum that we just arbitrarily write rules for.
No.
It is an active, layered architecture of emergent ontologies, each one orthogonally shielding the paradoxes of the layer beneath it.
It is a self-generating architecture. And while this provides a breathtakingly elegant philosophical framework for pure mathematics, the paper does not stop there.
No, it goes much further.
The authors make a much bolder, frankly staggering claim. They claim this is not just abstract philosophy. They claim this architecture is a generative mathematical program capable of literally reproducing the physical universe.
The physical universe.
The masses of particles, the shapes of atoms, the fundamental forces all derive from this exact logic of orthogonal closure.
Which is a huge leap.
Okay, I have to push back here because bridging that gap is historically where these grand unified theories fall apart. It is one thing to say math is built on orthogonal layers. It is an entirely different universe to say, therefore, the electron has this specific mass. How on earth does abstract mathematical closure generate actual, tangible, physical reality? How does a math concept turn into a rock?
This is the crux of the paper, where we transition from abstract ontology into the formal mathematical engine. And the absolute heart of that engine is a construct they call the coherence functional.
The coherence functional. Mathematically, it is denoted in the paper as a calligraphic C acting on a field state psi, right?
Yes, but we don't need the raw notation to understand its profound mechanics.
They call it the master variational quantity.
Exactly. In advanced physics, a functional is essentially an accounting tool. It takes an entire complex function, like a sprawling quantum field or a geometric shape, and it spits out a single scalar number.
So it scores it.
It acts as an evaluator. We use functionals constantly to find stable physical states because nature is inherently lazy. It loves to minimize things. A ball rolls to the bottom of physical valley to minimize its gravitational potential energy. Light bends through glass to minimize its travel time.
Right.
The coherence functional is doing this on an ontological level. It measures the structural cost of differentiation.
Structural costs.
It looks at the universe and asks, how expensive is it, in terms of ontological tension, to maintain this specific mathematical shape or physical state?
Wow.
The stable forms of mathematics and the stable particles of physics are simply the minima, the absolute cheapest, most stable valleys of this universal cost function.
The paper breaks this functional down into 3 specific taxes or terms that the universe has to balance. Let's translate these out of the math and into conceptual mechanics.
Let's do it.
First, there's a gradient term. This measures the cost of structural variation. Basically, it asks how sharply or irregularly is the field differentiated. If a physical or mathematical field is too jagged, too abrupt in its changes, it requires massive amounts of structural energy to maintain. The universe hates sharp edges. It's an expensive tax.
Exactly. The smoother, the cheaper. Second, there is a potential term. This encodes the favored closure regimes we just discussed.
Like the natural basins.
Yes. It evaluates the landscape and asks, toward what pre-existing structured domains does this field naturally tend to stabilize? Does one fold into a real number continuum or a complex rotation? It taxes states that try to avoid these natural basins of stability.
And third, the spectral term. This accounts for the organization of admissible modes. It asks, how does the internal harmonic organization of this shape affect its overall stability?
Yes.
So you have this universal coherence functional acting like a cosmic auditor, constantly trying to find the absolute cheapest, most stable configuration that satisfies these three demands without collapsing back into Zeta Naught.
And from this overarching functional, the mathematics induces a specific operator, the closure operator.
Closure operator.
When you apply this operator to the relational field and solve for its stable states, what physicists call solving its eigenvalue equation, something truly magical happens in the mathematics.
You get discrete admissibility.
You get natural quantization.
This is a huge, huge takeaway that I really want listeners to grasp. In standard quantum mechanics, we often just observe that things are quantized, right?
Right.
We look at an atom and see that energy only exists in specific, discrete stair steps, rather than a smooth ramp. And because we observe it, we write mathematical rules to force our models to behave that way.
We inject discreteness manually.
But in closure math, quantization isn't forced onto the universe from the outside observation. It naturally, unavoidably emerges as the isolated, mathematically stable modes of this specific operator.
Discreteness is not an arbitrary law. It is a structural necessity of closure. If a system is perfectly continuous, it is infinitely variable, which means it constantly bleeds structural energy.
It's too expensive.
Way too expensive. To achieve true closure, to lock into a permanent, cost-effective state, the field must isolate into discrete harmonic resonances.
Give me an analogy for that.
Think of a drumhead. When you strike it, it doesn't vibrate in every possible random way. The boundary of the drum forces the vibrations to instantly resolve into specific, discrete harmonic patterns.
Ah, I see.
Anything that isn't a perfect harmonic cancels itself out. The universe is a drumhead of orthogonal relations. Even the basic act of counting, the natural numbers, is just the very first, simplest, stable, discrete resonance of this operator.
So counting itself is a resonance?
The universe doesn't have counting thrust upon it.
Yeah.
Counting is the first stable eigenvalue of the coherence field.
Okay, that is wild, but it makes an intuitive kind of sense. So let's put this engine to the ultimate test.
Right.
If this math actually works, if this coherence functional actually describes the bedrock of reality, it should be able to naturally reproduce the shapes and masses of the physical universe without any cheating, without us programming the answers in advance.
It should.
Let's look at what the paper calls the physical recoveries, starting with the shapes of atomic reality.
We begin with the architecture of the atom, specifically the rotational shell law. In a rotationally balanced three-dimensional closure regime, which is what our local physical space represents, the framework's mathematical engine dictates that the angular spectrum must naturally organize into concentric shells.
Concentric shells?
Furthermore, the multiplicity of these shells, meaning the number of stable, discrete states allowed within each shell, is strictly governed by an exact derived formula.
And what is that formula?
$2 plus L1?
2L plus 1. Anyone who suffered through high school chemistry might suddenly feel a shiver of recognition. You are talking about the electron orbitals.
Yes.
The s, p, d, and f blocks on the periodic table. The s shell holds 1 orbital, the p shell holds 3, the d shell holds 5, the f shell holds 7.
1, 3, 5, 7.
That's the sequence 1, 3, 5, 7. That matches exactly with the output of $2 L plus a lumber, where the angular momentum quantum number L is 0, 1, 2, and 3.
It matches perfectly. And we must ask, why is this derivation so profound?
Why?
Because standard quantum mechanics usually just borrows this geometric law from pre-existing spatial assumptions. We observe the atom, we map it to 3D spherical harmonics, and we basically shrug and say, well, that's just how three-dimensional space forces things to behave.
You just accept the container.
But closure mathematics does not assume a pre-existing 3D space. It derives the $2 plus Willow 1 law purely as a necessary spectral outcome of balanced angular closure.
It creates its own geometry.
It mathematically proves that this specific sequence of shapes is the absolute most stable, cost-effective way for coherence to organize itself rotationally.
It doesn't just describe what the atom looks like, it explains ontologically why the atom has absolutely no choice but to have that specific geometric layout.
Exactly.
And the paper applies this exact same logic to mass, which is fascinating because normally we think of mass as just primitive stuff.
Right, like sand in a sandbox.
We imagine space-time as an empty stage, and mass is the actors we push onto the stage. We add substance to the universe.
But closure mathematics fundamentally, radically redefines what mass actually is. Mass is not a primitive substance. Mass is not stuff.
Then what is it?
In this framework, mass is mathematically defined as variational stiffness.
Variational stiffness.
Specifically, it is the second variation of the coherence functional around a localized closure extremum.
Okay, let's bring that down to earth. Let's unpack this idea of stiffness. Think about a physical guitar string.
That is an excellent mechanical analogy.
If the guitar string is loose and floppy, it doesn't take very much energy to pluck it, move it around, or distort its shape. Its resistance is low.
Right.
But if you turn the tuning peg and crank up the tension, the string becomes incredibly stiff. It takes a massive amount of energy to displace it even a millimeter. The mathematical curvature of the tension is incredibly steep. In closure math, the fabric of the universe is a relational field under varying degrees of tension. Shallow curvature in the coherence field means the stiffness is low, which translates physically to low mass.
Exactly.
A steep, dramatic curvature, where the mathematical field is tightly knotted and locked into a highly concentrated closure regime, means high stiffness. And that registers in our physical reality as high mass.
Precisely. Mass is nothing more than the field's relational resistance to dispersion. It is the structural cost required to move or alter a highly localized, deeply closed, coherent structure.
So particles aren't things.
Particles are not tiny, solid billiard balls bouncing around in a void. They are intensely, tightly knotted concentrations of closure. They are mathematical tension made manifest.
Wow.
And this conceptual leap brings us directly into the climax of the paper's physical recoveries, deriving the fundamental gauge forces of nature.
The 1-3-8 gauge hierarchy, I have to say, reading this section of the paper felt like watching a magic trick, but one where they actually show you the math behind the illusion.
It is stunning.
The framework doesn't just predict mass and atomic shapes. It attempts to derive the very forces that hold the universe together. Electromagnetism, the weak force, the strong force.
Yes.
And it does this using the exact same cost-saving logic we just talked about. It looks for the most economical, stable symmetries.
This relies on what the authors term the closure economy principle. The universe, acting through the coherence functional, desperately wants to build stable physical sectors while minimizing the overall closure cost.
Because nature is inherently aggressively economical.
To prove this, the paper provides a specific algebraic rank-weighted closure cost formula. The formula evaluates the complexity of a symmetry group and assigns it a cost based on 3 distinct penalties.
Let's break down how the universe taxes reality, because this is the literal recipe for the fundamental forces. The first penalty is for raw internal rank.
Internal rank.
This essentially says, do not make the internal dimensional hierarchy of this particle any more complicated than it absolutely has to be. Every additional internal dimension incurs a linear tax penalty.
Correct. The second penalty taxes generator complexity.
Generator complexity.
Now, the mathematics of continuous symmetries involves what we call generators. These are essentially the basic, indivisible mathematical moves or rotations you can make within that specific symmetry space.
Okay, so like the basic moves on a Rubik's Cube.
That's a great way to put it. The more generators a symmetry group requires, the more mathematically dense and complex the object is to maintain. The universe assigns a heavy penalty for the quadratic growth of these generators. It hates convoluted internal movements.
And finally, the third penalty. This is my favorite. It's a crowding penalty.
The crowding penalty, yes.
The paper dictates that this specific tax equals 0 for internal ranks 1, 2, and 3. The universe lets them slide. But the moment you reach rank 4 and above, this crowding penalty becomes strictly positive and scales aggressively.
Right.
It essentially acts like a microscopic zoning law. It says 3 internal dimensions is manageable, 4 is a crowd. If you try to pack a rank 4 geometric symmetry into a localized point, the spatial cost skyrockets and the structure destabilizes.
And when you take these 3 universal taxes, apply them to the mathematical landscape, and search for the absolute lowest cost minima, the most stable, irreducible mathematical configurations.
All you find.
Find exactly 3 stable internal ranks. They correspond flawlessly to ranks n equals 1, n equals 2, and n equals 3.
And nothing higher.
Any higher rank is taxed out of existence by the crowding penalty. Now, we take those 3 stable ranks and map them to their unitary symmetry generators.
This is where the magic trick happens.
For n equals 1, adjusting for the specific phase symmetry of U1, the mathematics yields exactly 1 generator.
Okay, what?
For n equals 2, the corresponding SU2 algebra dictates the number of generators is 2 squared minus 1, which equals 3.
3.
For n equals 3, the SU3 algebra dictates the generators are 3 squared minus 1, which equals 8.
1, 3, and 8. To anyone studying particle physics, those numbers aren't just a random mathematical sequence, they are the holy grail.
They are the foundation.
That sequence perfectly matches the exact gauge groups of the standard model of particle physics. U1 represents electromagnetism, which has exactly one generator, the photon.
Right.
SU2 governs the weak nuclear force, responsible for radioactive decay, which has exactly three generators, the W+, W-, and Z bosons.
Yes.
And SU3 governs the strong nuclear force, which holds the nucleus of atoms together, and it has exactly 8 generators, the 8 gluons.
It is a staggering derivation to witness. In traditional quantum field theory, the standard model is incredibly successful, but it is ultimately descriptive.
It just tells us what's there.
It takes these gauge groups as empirical inputs. We built massive particle colliders, we observed the photon, the bosons, and the gluons, and so we wrote their mathematical properties into the equations. We reverse engineered the math from the observation.
We measured the cake and then wrote the recipe.
Exactly. But closure mathematics suggests they aren't arbitrary empirical facts. The 1, 3 to 8 gauge ladder is the uniquely stable, minimal rank closure hierarchy selected by the universal cost function.
So they have to be that way.
The fundamental forces of nature exist in exactly this configuration because it is mathematically the cheapest, most stable way to build a functional universe out of orthogonal relations.
It makes you look at a wooden table or a rock or your own hand and realize that the impenetrable matter making it up is just math balancing its checkbook.
That's entirely accurate.
It's geometry settling into the cheapest possible configuration, which leads perfectly into a concept you touched on earlier. If matter is just stiff math, the distinction between a particle and a force basically vanishes.
Completely vanishes.
Matter is just what the paper calls deep closure.
Yes. The ontological wall between matter and forces entirely dissolves. Particles and forces are not two separate types of entities interacting on a stage.
Right.
Matter is simply what happens when the coherence field folds inward on itself so intensely, stabilizing its internal relational pattern so deeply that its variational stiffness prevents it from dispersing.
So matter is just tight math.
Matter is deep, highly localized closure. Forces are simply the interactive relations, the necessary mathematical translations between those stabilized closure domains. It is a single, unified topological fabric.
Okay, let's pull all these threads together. We have orthogonal differentiation constantly trying to pull the mathematical potential apart into independent, distinct directions.
Yeah.
And we have closure constantly trying to stabilize, lock down, and hold things together in economical shapes. What governs the ultimate relationship between pulling apart and locking together? Who is the conductor of this cosmic orchestra?
That brings us to the highest, most sweeping generative principle in the entire framework, the meta-operator.
The meta-operator.
The meta-operator is the ultimate balancing mechanism between two fundamental functions. First, the differentiating function, which is responsible for creating asymmetry, generating orthogonal emergence, pushing things apart, and creating spectral separation.
Okay, that's the pushing apart.
Second, the integrating function, which is responsible for creating symmetry, enforcing coherence, pulling things together, and ensuring persistence.
It is the ultimate cosmic push and pull, pulling the potential apart just enough to create distinct, measurable things, but pulling those things together tightly enough to keep them from disintegrating into chaos.
Exactly. And this tension leads to the grand, summarizing equation of the entire paper, the universal cohesion equation.
The big one.
The equation is stated as realized form equals the cohesive relation between differentiation and integration.
R equals K of D and I.
Yes. Realized form is reality itself. It states unequivocally that a realized mathematical domain or a realized physical universe is not identical with differentiation alone, nor with integration alone. Reality is the exact cohesive outcome of their lawful interplay.
It's the balance.
If the balancing act fails and you have too much differentiation, the system shatters. It succumbs to arbitrary fragmentation, total chaos, and cannot support complex structure.
And conversely, if you have too much integration, the system is crushed. It collapses back into undifferentiated uniformity.
Right.
It falls right back down the ladder into Zeta Naught, becoming a featureless lump of potential once again. Reality, whether it's the geometry of a complex number plane or the biological structure of a human cell, exists on a razor's edge, balanced exactly between explosive fragmentation and featureless collapse.
And the true beauty of this cohesive law is that it is scale invariant. It applies at every single level of the framework, from the subatomic to the galactic.
Which finally allows us to take a massive step back, zoom out from the equations, and look at the entire architecture of reality that this paper proposes.
We can see the whole map.
The paper charts a comprehensive map of existence from the absolute pre-spatial void all the way up to human consciousness, using the exact same mathematical logic of orthogonal closure and coherence. It outlines an ultimate ontology consisting of 4 distinct layers.
The 4 layers.
Let's walk through the architecture of the cosmos.
The primary layer is layer I, omnilectic invariance.
Omnilectic invariance.
This is the deepest, most fundamental bedrock. It is the home of Zeta Naught. It is pure, pre-differentiated possibility. It is crucial to understand that layer 1 is not mathematics yet. It is the ontological condition that makes the emergence of mathematical logic possible.
Then the tension breaks, and we move to layer 2, the Hall electric field.
Right.
This is where orthogonal differentiation first happens. The potential splits. Distinct directions emerge without violating symmetry. The bivector is born. Mathematics technically begins here.
Which naturally stabilizes into layer 3, relational structure. This is where the physical universe as we experience it actually lives. This is the domain of physical physics.
Particles, atomic shells, the 138 gauge forces, the curvature of gravity.
Yes. Coherence stabilizes into measurable physical interaction. Even space-time itself is redefined here. Space-time is not an empty container holding the universe. It is the unified mathematical projection of coexistence relations within the stabilized field.
The field creates the space it needs to express its relations. And then, the ultimate leap. Layer 4, derived structure. This is the layer of biology, life, the mind, technology, and human civilization.
It's us.
And what I find so deeply moving about this section of the paper is how it treats us. It doesn't treat biological life or cognitive thought as weird alien accidents that randomly sprouted in a cold, dead, mechanical universe.
Oh, it doesn't.
It treats biology as a lawful, mathematically necessary, higher-order continuation of the exact same emergence ladder that created the proton.
Exactly.
Yeah.
The transition from chemistry to biology is just another orthogonal projection of coherence. Biological life and human cognitive civilization are explained mathematically as coherence engines.
Coherence engines.
We are highly specialized systems that actively preserve, restore, and amplify coherence under the threat of finite entropy. When a cell maintains its cellular wall against a chaotic environment, it is performing an act of mathematical closure.
We are literally the universe continuing its process of stabilizing itself. A coherence engine. It is such a powerful phrase. It totally changes how you have to conceptualize cosmology and the Big Bang.
It really does.
If you buy into closure mathematics, the Big Bang wasn't just a brute, dumb explosion of hot stuff rapidly expanding into a pre-existing empty space. The paper forces us to describe it more like a big emergence, a cosmic projection sequence.
Unfolding layer by layer.
The history of the universe is simply the logic of coherence steadily unfolding itself, layer by layer, finding new ways to stabilize its own internal tension.
And as it unfolds, as it pushes the boundaries of the differentiating function, it produces intermediate regimes of organized openness. We call that complexity.
Right.
But this raises a final, vital question about the limits of this expansion. If everything is just a stabilized closure regime, if the universe is just a sequence of bounded mathematical domains, where does the concept of infinity fit into all this?
Right. Because if everything requires closure to exist, infinity seems like the ultimate violation of closure. It never closes. Is infinity just a really, really big number sitting outside the universe waiting for us?
No. And that is why infinity is entirely demystified and redefined in this framework. Infinity is not a magical, mystical number. And it is certainly not a physical place or a spatial destination you can travel to.
So what is it?
In closure mathematics, infinity is defined strictly as an unbounded closure regime.
An unbounded closure regime.
It is a structural boundary condition. It occurs precisely when the differentiating function within a specific domain begins to massively outpace the integrating function, allowing the admissibility of new relations to become structurally open-ended.
It just keeps going.
Infinity isn't an object. It is a behavioral property of the closure rules themselves when the balance tilts heavily toward differentiation.
So let's recap this incredibly dense paradigm-shifting journey. We started with the realization that the foundation of mathematics doesn't actually begin with an empty box, a void, or the number 0. 0 is just a local "you are here" marker, a coordinate veil projected by a system that is already highly structured. The true bedrock of mathematics and reality actually starts with Zeta Naught, an isotropic state of pre-differentiated, perfectly balanced potential.
From that state of potential, the first lawful structural act is orthogonality, the simultaneous emergence of independent bivector relations that break symmetry without establishing arbitrary dominance.
Those raw, independent directions must then stabilize into persistent mathematical domains through the mechanism of closure. Mathematical worlds, the integers, the real numbers, the complex plane are not inventions, they are necessary. Orthogonal closure layers structurally shielding the paradoxes of the layers beneath them.
And this philosophical framework powers a rigorous formal engine. The coherence functional acts as the cosmic auditor, seeking the lowest structural cost for reality.
And this functional, through the closure operator, naturally and unavoidably produces discrete quantization. The universe is quantized because continuous forms bleed energy.
Yes. This engine derives the specific $2 L plus angular shells of atomic chemistry. It redefines the very concept of mass, showing it to be nothing more than the variational stiffness of the field, the mathematical resistance to structural dispersion.
It uses the brutal logic of the closure economy principle to tax mathematical complexity, naturally deriving the exact 138 gauge hierarchy of the fundamental forces of nature.
And it unites this entire sprawling architecture under the meta-operator and the universal cohesion equation. It proves that reality is a four-layer, unbroken topological structure, stretching from prescalar invariance through mathematical logic, through the physical universe, all the way up to conscious life.
It is truly a breathtaking attempt to unify ontology, mathematics, and quantum physics into a single, cohesive theory of emergence. It makes you realize that the math we learn in grade school is just the tiny, stabilized tip of a massive cosmic iceberg.
I want to leave you with a lingering thought that builds directly on the text's beautiful definition of biological life as the coherence engine.
Okay, lay it on us.
If human consciousness is essentially a highly complex reflexive coherence engine operating at layer 4 of this grand architectural stack, a specialized system capable of recursively analyzing and modulating its own internal coherence, then when you, the listener, sit down, read this paper, and study closure mathematics, are you simply the universe's mathematical field, finally achieving the necessary layer of closure required to conceptualize and understand itself? Wow. If that doesn't make your head spin, nothing will. Next time you write down the number 0 or look at a standard mathematical equation, I guarantee you will look at the entire concept of nothingness in a completely new light. It is not the bottom of the box. It is just a veil, hiding the roaring potential underneath. Thanks for joining us on this deep dive.